Okay, so let's see another question. This is second part of the previous question. The ultimate stress in Newton per millimeter square of the work material is. So let's see. So the shear stress can be written as shear force over shear area, that is B into T1 over sine phi. So with the help of this formula we can determine tau s, and we already found Fs shear force, that is nothing but this is 751.04 Newton over width is already given here, that is 2.5 millimeter into uncut chip thickness is 0.25, and sine phi is already we determined in the previous question, that is 18.375. Is it right? So now if we simplify this, then after simplification here we get exactly 380 Newton per millimeter square. So the correct answer is option D. Okay, so let's see another question. So match the following material with your most appropriate application. So you can see low carbon steels. It is mainly used for making car body. So one is stainless steel. It is used for making utensils. So this is R. Rake cast iron. You can see it is mainly used for making machine tool. Base. Why it is? Because it is having very good damping capacity. Is that right? And titanium alloy is mainly used in aircraft industries. So this is Q. So SRPQ. SRPQ. So correct answer is option D only. Next, the number of defective produced by 6 sigma process in parts per million. So in 1 million, in 6 sigma, correct, 6 sigma quality standard, in 6 sigma quality standard, out of 1 million parts, only 3.4 parts will be a defective parts, are defective. Is it right? Means if you produce 1 million parts, then only 3.4 parts can be defective. So this is called a 6 sigma quality standard. And according to this, there is no such option. So here I am choosing most appropriate one, that is option C. Next, the quick return mechanism used in shaper has rocker arm drives of length 200 mm. If the crank radius is 50 mm and the offset length is 20 mm, then the stroke length is. So you can see here in this question, OC is given, that is 200 millimeter. AB is also given here, that is 50 millimeter. And the offset between crank center and the rocker arm, this A is a crank center and O is a center of rocker arm, and about this, and this is, you can see this is a hinge point, so that the crank and the rocker arm can oscillate. Is that right? So this OA distance is nothing but this is already given here, 20 millimeter. So let's suppose if I consider this is an alpha angle, so triangle OAB, can I say sine alpha, which is nothing but, and you can see OB is a base, AB is a perpendicular, and OA is a hypotenuse. So sine alpha is nothing but it can be written as perpendicular upon hypotenuse, that is OA. Is it right? Similarly, from triangle OCD, again you can see this alpha is a common for both the triangles. So can I say from this sine alpha is nothing but it can be, in this case CD is a perpendicular, OD is a base, and OC is a hypotenuse. So can I say in this case this is nothing but this is CD by OC. So let's suppose this is equation 1 and this is equation 2 and both are sine alpha. So can we put both the expressions? So from this we can get AB by OA, this is equal to CD by OC. So after equating both the terms, from this CD can be written as AB into OC over OA. Is it right? And now what about stroke length? Total stroke length is nothing but this is C. And what is C? This is 2 times of CD. Yes or no? So you can see here C is nothing but 2 times of AB into OC over OA. And from this you can see here, if I put all the values here, so AB you can see here it is given here 50 millimeter, and what is OC, this is also given here, that is 200 mm, and what is OA, this is 20 mm. So if I simplify this, then you can see this is 10, so 500 into 2, that means C is 1000 millimeter, or it can be written as C is equal to 1 meter. Is equal to 1 meter, and this is the right choice. So the correct answer is option B. So I hope you will understand how to determine stroke length in single-sided quick return motion mechanism. Okay, so let's see another question. List 1 and list 2. So list, you can see here option A, this is chatter. Chatter means unusual sound produced during machining, and it is mainly caused due to more vibration. When the rigidity of your tool and workpiece is not accurate, then this thing is happen generally. So lack of rigidity in machining, fixtures, bars or workpiece, chatter can be occurs. Yes or no? So this is A2. Next, poor surface finish. So I already told you the maximum roughness during machining is, it can be written as F square by 8R. So as you increase F that is feed, H max will be increases. So therefore surface finish get deteriorated. Yes or no? Surface roughness increases. Yes or no? Surface roughness increases, or you can say poor surface finish can be get. Is that right? So the correct choice for this option is too high feed. Yes, too high feed. That is this is 2 and this is 1. So let's see 2 1 2 1. Yes, and here 4 5. So option C and D is wrong. Either we have A option or B option. Next, loss of accuracy. So high cutting load, radial relief too great, and not enough lubrication. So I don't know actually about this. Next we see cutter burns. Cutter always burns when excessive heat will produce. Is it clear? Cutter always burns due to excessive heat produced, and excessive heat can be produced when there is not enough lubrication is provided. Is it right? So for option 4, the best choice is option 5. So according to this, if I say so D5, so the correct answer is option B. So let's see what about loss of accuracy. The loss of accuracy is nothing but it depends upon cutting load. So this is not correct answer, but yes, you can say this is appropriate answer. So according to these options, the B option is more appropriate and more correct. Okay, so let's see another question. One brand of milling machine has the following 2 index plates supplied along with the indexing head. Plate 1, in which we have 15 holes, 16. Actually this represents, let's suppose we have a plate. Is it right? So let's suppose in this inner, here we have 15 holes, let's suppose, and here we have another holes like this. Yes or no? In indexing plate we have holes like this. Is it right? Is that right? So in first, you can see first in this we have 15 hole, let's suppose in this we have 16 hole, in this we have 17 hole, like this. And similarly another plate we also have in which the number of holes are represented. Is it clear? So this is a indexing plate. Is that right? Correct. So the actually this numbers represents the number of holes in a circumference. So it is proposed to mill a spur gear. So with the help of these indexing plates, we need to produce a spur gear with 28 tooth using simple indexing method. So which one of the following combination of indexing plate and the number of revolution is correct? So you can see here the number of revolution for simple indexing is nothing but it can be written as 40 by Z, where Z n is a speed, number of revolution of what? Number of revolution of indexing plate, and Z represents the number of teeth that we need to produce on the blank. Is it right? So according to this formula, if I use, so it can be written as 40 by Z, which is 28 teeth. So if you simplify this, then here we get 10 by 7. So there is no such option, yes or no? So this 10 by 7 can also be written as 1 into 3 by 7. Is it clear? 1 into 3 by 7. So from this we can say one complete revolution. This one represents one complete revolution required. And after that, how much? So 3 by 7. So yes, there is no such option. None of the plate has this. So simply if I multiply with 3 over 3, so after getting this, we can get 9 by 21. 9 by 21. So this represent one complete rotation of indexing plate of plate 2 with 9 holes in 21 hole circle. Is it right? मतलब यहाँ पे क्या होगा कि 21 होल सर्कल में प्लेट 2 में, क्यों? Because in this plate 1 you can see, you can't see the 21 number of holes plate, 21 number of hole circle, yes or no? So 21 whole number circle is given in the plate 2. That's why the plate 2 is the right one. So this one option is right, and this one is wrong. So one revolution, yes, one revolution is also right. 9th hole in 21 hole, yes, 9th hole in 21 whole circle, and this is 39th hole of 33. So option C is wrong. So the correct choice is option B. Is that right? So like this you can solve this problem. Next question you can see, consider the following statement: the helical fluid in a twisted drill provides the necessary. So let's suppose first here I am going to draw a helical gear tooth. This is called dead point, or simply we can say dead, sorry, point only. And this is cutting edge. This is cutting edge. And let's suppose this is cutting edge 1. So this one is cutting edge 2. Correct? So obviously this is a twisted drill in which we have 2 cutting edges, or these cutting edges are also called as lip. So obviously this is lip 1 or this is lip 2, and the angle found between this is called 2 alpha, and this 2 alpha is nothing but this is point angle or dead angle. This is also called as point angle, or this is also called as dead angle. Is it right? And you can see here, this is the passage through which a chip can be removed. Is it clear? This is chip. which can be removed. So this passage is called as fluid. This passage is called as fluid. Yes or no? This passage is called as fluid, correct? And this fluid is provided to remove this chip. Yes or no? And let's suppose if I draw a tangent, with this land of the fluid, so this angle is called as, let's suppose this is theta. So theta is called as helix angle. This is called as helix angle, or it also called as rake angle. Helix angle or rake angle. Is it right? So this is basic information of this tool, and obviously this is a tool axis or drill axis. Is it right? So now let's see the correct choice for this question. The helical fluid in a twist drill provides the necessary clearance angle for the cutting edge. No, this is not clearance angle. Rack angle for the cutting edge. Yes. Rack angle of the cutting edge. Yes, it is right. Theta. Helical fluid in a twist drill provides the rack angle for the cutting edge and space for the cut chip come out during drilling. Yes, this is also right. Guidance for the drill to enter into the workpiece. This is wrong. So the correct choice is option 2 and 3. So the correct choice will be option B. Okay. So let's see another question. A 40 mm through hole is to be drilled in a 30 mm thick plate using double fluid with the drill bit is given here, that is 20 millimeter in a 30 mm thick plate. So let's say this L is 30 mm. The drill tip at a distance. So let's suppose if I first here I'm going to make a workpiece. So this is a drill bit. Let's suppose we have a drill bit like this, and this gap is provided here. This is the length of the workpiece, correct? So let's suppose this is the approach which is equal to 3 millimeter, which is given in the question. Surface when the cut, and yes, the flute angles means, sorry, dead angle, that is 2 alpha is given here 120 degree. So from this, can I say alpha is nothing but 60 degree. Remove from the plate surface when the cutting is started, and an over travel of 2 millimeter is recommended. Means your tool can move from here to here. Two millimeter, and this length is also required. So this length is L, which is equal to 30 mm, and this is over travel, which is 2 millimeter, and this is X, which is nothing but this is D by 2 cot alpha, or simply we can say 20 by 2 cot 60 degree. And if you solve this, then simply here I am getting let's see, first here I am going to calculate this value. .7, and this is A, which is equal to 3 millimeter. Is it right? So this information is already given in the question. Correct? And after that you can see the number of revolution is also given here, that is N is equal to 500. RPM, and feed per tooth is also given here, that is F 0.01 millimeter per tooth. But actually here we have two tooths, so feed per revolution can be written as 0.01 into 2, that is millimeter per revolution. So here we get 0.02 mm per revolution. Is it right? Don't forget to change this value. Is it right? So we need to find out machining time. So as you know that the machining time is nothing but this is L by Fn. So now if I put all the values here on this expression, okay, so the length is nothing but this is approach length plus small l plus over travel plus x over Fn. So now if I put these values here, so this is 3 plus 30 plus 2 plus 5.77 over 0.02 into revolution is 500. And yes, here we need to find out in minutes. So simply you just calculate this value. So here I am getting plus 2 plus 30 plus 3 divided by 0.02 divided by 500. So after getting this, here I am getting 4.077 minute. And according to this, the most appropriate answer is option A. Otherwise, none of the option is absolutely correct. Is that right? So like this, you can solve this problem. And now you can see a non-standard thread of pitch 3.175 millimeter is to be cut on a lathe having lead screw of pitch 6 millimeter. A change gear set provides with the lathe has one gear each with the following number of teeth: 20, 30, 40, 50, 60. This the correct pair of change of gear A by B cross C by D for machining the given threads are assumed that the transformation ratio for the rest of the kinematic train between the lathe spindle and lead screw is equal to. So actually we need to find out transmission ratio, which is also called as gear ratio. Transmission ratio, which is also called as gear ratio. And this gear ratio is nothing but this is pitch of the job thread which we need to produce. Is it right? Over pitch of the lead screw of a machine. Is it right? So according to this, if I see, and in short, if I write GR, or it is also written as TR. Is it clear? Gear ratio is also written as TR, transmission ratio. So this is equal to the pitch that we need to produce is 3.175 millimeter over the pitch of the lead screw is 6 millimeter. So now for conversion of this value in the integer form, we just multiply with 40 over 40. So after multiplying this, here I am getting 127 over 6 into 40, and denominator I am not converting because none of the options is given like this. So simply here I am writing 127 over 6 into 40. So obviously the numerator will be converted into integer form. So let's see, because why here I need to write A by B into C by D ratio form, correct? So can I say this is 127 over 40 into 1 by 6. 127 by 40 is given here, but this term is not given. So if I multiply with 20 by 20, so from this we get 127 by 40 into 20 by 120. So this is the correct transmission ratio. Means we assembled the gear like this. 127 gear tooth will be connected with 40 tooth and 20 is connected with 120. So when you connect these gears like this, then you can make a standard thread with 3.175 millimeter pitch. So this one is the right answer. So option B is the right choice. Okay, so let's see another question. The figure shows an incomplete schematic of a... Okay, so now it is visible, I think. The figure shows an incomplete schematic of a conventional lathe to be used for cutting thread with a different pitch. The speed gearbox UB is shown and the feed gearbox US. So US is a feed gearbox, UB is a speed gearbox. UB is a speed gearbox and US is a feed gearbox. Feed gearbox means this is a gearbox which is provided to the lead screw, so that we can engage the feed rod with the lead screw for providing automatic tool translation along the work axis. Is it right? Is to be placed PQRS. PQRS is the location and have no other significance. Change in UV should not affect the pitch of the thread being cut, and the change in US should not affect the cutting speed. So the correct connection and the correct placement. So let's suppose if I zoom, correct connection and the correct placement of US are given below. So US is a feed gearbox. Then obviously you can see this is a workpiece. This is a workpiece which is fitted on the chuck. Yes or no? And this chuck is connected with this gearbox. This chuck is connected with this gearbox. So this is a motor, electric motor. And this is gearbox, speed gearbox. So with the help of this speed gearbox, we can control the speed of the spindle. You can see this, here we have a spindle in which we have a chuck. On the chuck we can put our workpiece. Yes or no? And now this is the lead screw. Obviously this is the lead screw and this is the tool, and this lead screw is connected with the feed rod with the help of half nut. Correct? So we need to find out the correct connections and the correct placement of US. So you can see here Q and E are connected. Q and E are connected. So this is absolutely wrong. Q and E is not connected because E is connected with the workpiece. Yes or no? Is it right? So SE connection is the right choice. SE connection is the right choice. So either this one or this one is right choice. This one is wrong. And next, US is placed between R and S. US is placed between R and S. So US never be placed between R and S because this spindle is directly connected with the workpiece. So no meaning of this feed. So option B is wrong. Option and US is placed between S and E. S and E. Yes, US is placed in between S and E. So this is the right choice. Yes, obviously the feed gearbox is provided in between lead screw and the workpiece. Yes or no? So that we can provide the relative motion of the tool with respect to workpiece along the axial direction. So the correct choice will be option D. Is that right? Okay, so let's see another question. A 600 millimeter by 30 millimeter flat surface of a plate is to be finished machined on shaper. This is shaper machine. The plate has been fixed with 600 mm. You can see here. So this is length which is equal to 600 millimeter, and this is width which is equal to 30 millimeter. Plate and the shaping operation performed along this direction. Along the tool travel direction. If the tool over travel at each of the plate, means your tool moves from here to here. So this is over approach and this is over travel by how much amount? By 20 millimeters. So this is 20 millimeter extra and here we have 20 millimeter extra. So the total length traveled by the tool is nothing but this is 640 millimeter. Correct? And the feed rate is also given here. This is equal to 0.3 millimeter per stroke. The ratio of return time to cutting time means T2 by T1 is also given here, that is 1 by 2. The time required for machining will be, so we need to calculate total machining time, which is nothing but it can be written as T1 plus T2 into capital B by F. Is it right? So from this, if I say this relation can also be written as, if I take T1 as a common term, so it can be written as 1 plus T2 by T1 into B by F. Yes or no? And what is T1, T2? T1 plus T2 is a time taken for one stroke and B by F represents the number of strokes. So once again you can say Tm is nothing but instead of T1 can I write L by V1 in bracket 1 plus T2 by T1. So this is our final expression. So before putting the values, first you simplify the expression. Now if I put the values, then here we get 640 and velocity is given here. Velocity is not given here. Actually, we need to determine this velocity. No. Yes, velocity is also given. No need to worry about this. This is 8 meter per minute. So can I say 8000 millimeter per minute? Yes or no? 1 plus this is 1 by 2 into 30 by 0.3. So when you simplify this, then here we get 640 by 8000 into 1.5 into 100. And after simplification, how much time we get? This is 12 minutes. This is 12 minutes. Exactly 12 minutes we get. So the correct answer is option B. So like this, you can solve this problem. Next, two holes of 10 mm diameter are to be drilled in a steel plate of 20 mm thickness. Drill spindle speed is 300 rpm. So let's suppose if I write two hole of 10 mm diameter. So diameter of the drill bit is given here, 10 millimeter, are to be drilled in a steel plate of 20 mm thickness. So let's suppose L is 20 millimeter. Drill spindle speed, that is N, is given here 300 rpm. Speed is also given here, that is 0.2 millimeter per revolution. And the drill point angle means 2 alpha is given here 120. So from this can I say alpha is 60 degree. And assuming drill over travel is nothing but 2 millimeter. O is a over travel. So the time producing a hole will be, so machining time we need to calculate. So as you know that L is nothing but it can be written as small l, and approach is obviously not given here, the small l plus x plus over travel. Yes or no? So now, and what about x? X is nothing but this is d by 2 cot alpha. So here we have d is 10 by 2 cot 60 degree. So if you simplify this, then here we get, so here I am getting 2.886. This is 2.886. So now if we put these values here, then simply here we get 20 millimeter plus 2.886 plus 2. So total length is 24.886 millimeter. So what about machining time? So machining time is nothing but this is L by Fn. So L is 24.886 and speed is given here. How much? That is 0.2. And what about speed? This is 300 rpm. So now if we sit, and yes, this time is given in second, so simply we multiply with 60 because this is the RPM revolution per minute. So after simplifying this, here I am getting 25 second. 25 second. So the correct choice is option B. Okay, so let's see another question. The time taken to drill a hole through a 25 mm thick plate with a drill rotating at 300 rpm, moving at a feed rate of 0.25 millimeter revolution. So yes, for determining over travel approach or X, none of the information is given here. So simply if I say the machining time is, this is L by Fn. So L is given here, that is 25 mm thickness, over feed is given here, that is 0.25 into 300 rpm. So if you simplify this, and yes, here the time is given in the seconds, so simply if you multiply with 60, then after simplifying this, here I am getting 20 second. 20 second. So this is very simple question. So according to this, the correct choice will be option B. And now you can see next question. If each abrasives given in the viewed as a cutting tool, then which of the following represents the cutting parameters in the common grinding operation? So listen, in the grinding operation, you can see, let's suppose this is a grinding wheel in which a multi abrasive particles, yes or no, like this. So simply can I say this is in this we have interrupted cutting, or you can say discontinuous cutting. And whenever we have interrupted cutting, then we need strong cutting edges. And how we get strong cutting edges? So strong cutting edges can be get by giving large negative rack angle. Large negative rack angle means it is looking like this. This is the front view of the tool. If your rack angle is looking like this, then this is called as negative rack angle. Yes or no? If you have large rack angle, then obviously your tool becomes stronger. Yes or no? And so the large negative rack angle is right. So this one is wrong. This one is wrong. Correct? Rack angle and low shear angle. So what do you mean by low shear angle? Low shear angle means less contact length. And if you have less contact length, then obviously the chances of tool wear will be lower. So this is suitable. So large negative rack angle and high shear angle. So this option is wrong. So correct choice is option A. And obviously high cutting speed always provided to the tool so that high heat deposition takes place. High heat dissipation. High heat dissipation takes place. So suitable parameters are large negative rack angle, low shear angle, and high cutting speed. So option A is the right choice. The abrasive material used in grinding wheel selecting for the grinding of ferrous alloys. So ferrous alloys, while machining ferrous alloys, we always choose such tools which does not have carbon. Yes or no? So the correct answer is option C. Otherwise, in silicon carbide we have carbon. In diamond it is an allotrope of carbon. Boron carbide is also a carbide of boron. Is it clear? That's why these three options are not suitable. So the correct choice will be option C. Okay, so let's see another question. Determine the transformation ratio. Transformation ratio is nothing but this is also called as gear ratio, and gear ratio is nothing but this is a pitch of job thread over pitch of, I already told in the previous question, pitch of spindle lead screw. Is it right? So the transfer ratio is nothing, but transmission ratio is nothing, but you can see here the lead screw of 4 TPI. What do you mean by 4 TPI? 4 TPI. 4 TPI means 4 threads per inch. Is it right? So this is called pitch. So simply can I say the pitch of lead screw is nothing but is 25.4 millimeter over 4. And what do you mean by 25.4? Because in 1 inch we have 4 threads. So how much distance is traveled for one thread? So as you know that in 1 inch we have 25.4. 1 inch is equal to 25.4 millimeter. Is it right? So that's why here I am writing this. So after simplifying this, here we get 6.35. Correct? So pitch of the lead screw is 6.35, and we need to cut 1 millimeter pitch screw thread. Yes or no? So here ratio can be written as pitch of the thread, which is already given here. Pitch of the thread is already given here, that is 1 millimeter, and pitch of the lead screw is also given here, 6.35. So now if I simplify, then here I am getting 100 by 635, and now if we simplify, if you divide with 5, so simply here we get 20. 5 to the 10, so this is 20 over 20 by 127, and this result is not possible. So simply gear ratio or transmission ratio can be written as 127 by 20. So the correct answer is 127 by 20. This is the right answer. Okay, so let's see another question. So this is a designation of grinding wheel. So let's suppose first here I am telling you what is the designation of grinding wheel. So generally it can be written as AGBSB. So this represents A27 A7V. Is it right? So this represents types of abrasives. Abrasive, and A indicates aluminum oxide, that is Al2O3. This represents grain size, and 27 represents coarse grains. K represents grade of the grinding wheel, and K represents soft grade, and 7 represent structure, and here the 7 represents open structure, and this represents binding material, and V means vitrified. Is it right? So this is the meaning of this designation. So finishing, here we need to perform finish grinding. So remember, for finish grinding, we always required fine grains, but in this we have coarse grains, so this is not accepted. So according to this, is this an appropriate choice? So this is not. No, because abrasive is not correct. No, abrasive is correct. For machining iron based alloy, we always use aluminum oxide, but this This is not a right choice. No, grain size is not correct. Yes, option C is the right one. Grain size is not appropriate because for finish cut we always use fine grains, but here we have coarse grains. That's why this choice is not correct. This is wrong choice. Okay, a milling cutter having 8 teeth is rotating at 150 rpm if the feet per tooth is given 0.1. So you can see here Z is given, that is 8, N is given, that is 150 rpm, and feet per tooth this is also given here, that is 0.1 millimeter. So the speed in millimeter means we need to find out table feed actually. Correct? So table feed is nothing but this is Ft into N into Z. Now if we put these values here, then this is 0.1 into 150 into 8. So after simplifying this, here I am getting 120 millimeter per minute. So the correct choice is option A. Next, a milling cutter having 10 teeth is rotating. Yes, once again you can see 10 teeth is rotating with 100 rpm. The table feed, yes, now in this case we have table feed, which is equal to 50 millimeter per minute. So here we need to find out feet per tooth. Feet per tooth. So feet per tooth is nothing but this is F, Y and Z. This is 50 over 100 into 10. So 5 by 100, or you can say Ft is nothing but this is 0.05 millimeter per tooth per revolution. So the correct unit is feet per millimeter per tooth per revolution. So the correct choice will be option D. Okay, so let's see another question. For cutting double start screw threads of the pitch 1.0 millimeter on the lathe, the thread cutting tool should have feed rate. So for feed rate, of double start screw thread equals to 2 into pitch. So this is equal to 2 into 1. So here we get 2.0 millimeter per revolution. So the correct choice is option C. What about next question? Two separate slab milling operation 1 and 2 are performed with identical milling cutter. The depth of cut in operation 2 is twice that in operation 1. So can I say the depth of 2 is nothing but this is twice of depth of 1. So we need to find out the ratio of T max ratio of maximum uncut chip thickness in operation 1 and 2. So T max 1 over T max 2 we need to determine. So T max 1, that is uncut chip thickness, is nothing but this is, it can be written as Fy and Z, 2 times of Fy and Z, square root of small dy capital D. So simply can I say 10 T max 1 is directly proportional to square root of D. So T max 1 by T max 2 is equal to square root of d1 by d2. So square root of d1 by d2 is nothing but this is 1 by 2. And if you simplify this, then here we get T max 1 by T max 2 is nothing but this is root 2 or sorry, 1 by root 2 or 0.707. Is that right? So the correct answer is 0.707. Next, which of the following powder production method produces sponge and porous particle? So remember, this reduction of metal oxide is always used. In manufacturing of twist drill, the shank is joined to the body of the drill is using friction welding is used. Which of the following gear manufacturing process is based on generation principle? So gear hobbing is such method. Two final finishing process for the surface plate made of cast iron which is used to reference surfaces. So the correct answer is buffing operation. Is it clear? Buffing operation. In a saper machine, the mechanism for tool feed, that is Whitworth quick return mechanism. Tool life in case of grinding wheel is the time. Tool life in the case of grinding wheel is the time between two successive wheel dressing. Don't be confused with between two regrinding, because in grinding wheel we never do grinding operation. Here we do dressing operation. Is it right? The cutting operation of the drill is to be welded to its shank by friction welding. Why I am reading this too much question? The flank of the teeth of rake type gear cutter used for cutting involute gear profile are involute. The drawing process shown is machine surface, machine shaft. The purpose of providing rounded grooves at M and N is, its purpose is providing lubrication, supply lubricant oil for bearing mountings. Which one of the following is not a synthetic abrasive material? So titanium nitride is not a synthetic abrasive material. Is it right? Internal gear cutting operation can be performed by shaping with pinion cutter, shaping with rake cutter. So which one is the right answer? So the correct answer is shaping with pinion cutter. Lead screw with half nut in a lathe free to rotate in both directions uh, have Acme thread. Is it clear? Acme thread is the right answer. Deep hole drilling, a small diameter say 0.2 millimeter is done with EDM by selecting the tool material, that is copper wire. Abrasive metal used in grinding wheels, selecting the grinding ferrous alloys. I already told you aluminum oxide. Helix angle for fast helix drill is normally used 35°. Plain milling of mild steel plate produces irregular shape discontinuous shapes. Regular shape discontinuous. Yes, regular shape discontinuous shapes. Why discontinuous shapes? This is the interrupted cutting process, so in which we always get discontinuous shapes. When 1% plain carbon steel is slowly cooled from the molten state to 740, so resulting structure will be. So let's suppose if I draw iron carbon diagram, not completely but partial. So it is looking like this. Is that right? So if I represent all the important points, so obviously you can see here we get austenite, here we have alpha, here we have alpha plus gamma, here we have gamma plus Fe3C, and here we have alpha plus Fe3C, which is called perlite. Is it right? And here we have, this is commonly known as perlite. So here we have alpha plus perlite, and here we have alpha plus cementite. Sorry, perlite plus cementite. Is it right? So yes, your point is lie on somewhere here. Is it clear? Because this is a 0.8% carbon, this is 2.1% carbon. So let's suppose this is 1% carbon. This is 725. So can I say this is 740 degree centigrade? This is 1150. This is 910. So at this point we have gamma plus Fe3C, that is austenite plus cementite. So option D is the right choice. In a small lot production for machining, each slot on machining table is expected to use, yes, we use vertical milling. Minimum dimension and accuracy can be obtained in the cylinder bores of automobile engine. So this is lapping. So in an orthogonal machining operation, the cutting and thrust force are equal. means FC is equal to FT. Uncut chip thickness is given, T1 is equal to 0.5 millimeter, and the shear angle phi is 15 degree, it is also given. The orthogonal rack angle of the tool alpha is 0 degree, and the width of the cut is 2 millimeter. The workpiece material is perfectly plastic and the yield strength tau s is 500 megapascal. The cutting force, we need to find out cutting force is equal to, so as you know that shear force is nothing but F tau s into V into T1 over sin phi, and instead of W if I write B, width of the chip. So from this we can write 500 into 2 into 0.5 over sine 15 degree. So after simplifying this, here I am getting 1931.85 Newton. This is shear force. And after getting shear force, as you know that shear force is nothing but this is FC cos alpha, sorry, not alpha, phi minus FT sin phi. Is it right? So as you know that FC and FT is same, so can I say Fs over cos phi minus sin phi? So this is 1931.85 over cos 15 minus sin 15. And if you simplify this, then here we get 2732.04 Newton. Is that right? So this is the right answer. Let's see another question. A surface grinding operation has been performed on a cast iron plate having dimension 300 by 10 by 50. So let's suppose if I draw, this is a work surface. We have a work surface like this. Is it right? 300 length, 10 millimeter width. So length is equal to 300 millimeter, width is equal to 10 millimeter, and the height is 50 millimeter. Is it right? The grinding was performed using an aluminum wheel having alumina wheel means aluminum oxide wheels with a diameter of the grinding wheel 150 mm. Wheel width is 12 mm, means whole width is covered in one run. The grinding velocity is 40 meter per second. Table speed is 5 meter per minute. Table speed means F feet, that is 5 meter per minute. Depth of cut per pass means you need to remove this much amount of material. Is it right? So this is called depth of cut, and this depth of cut is given here 50 micrometer. And the number of grinding passes, let's suppose small n, this is equal to 20. The average tangential, and you can see if you have a grinding wheel like this, so the tangential force may act like this and normal force may act like this. So the tangential force, which is called as cutting force, which is 40 Newton, and this normal force, that is thrust force, which is 16 Newton respectively. The value of specific grinding energy, we need to calculate U, which is nothing but Fc into V over MRR. And what is MRR? MRR is nothing but volume of the material removal over machining time. So if I say the volume of the material removal, so can I say this is 300 into 10 millimeter, and how much material removed? 50 microns. So 50 into 10 to the power minus 3 millimeter. Over machining time is nothing but this is L by Fn. Is it clear? And the length is 300 over speed is given here, that is 5 meter per minute, So no need to write directly, you can use 300 by 5 meter or 5000 meter per minute. So if we multiply with 60, then we get in second. Correct. So after simplifying this, here I am getting 41.66 millimeter cube per second. So now you can see the specific energy is cutting force, that is 40 Newton. Velocity is given, that is 40 meter per second, over MRR is 41.66. So no need to convert any unit. You just calculate this, and after calculating this, how much we get? Let's see. This is 38.406 joule, because this is Newton meter per second and this is millimeter cube per second. So joule per millimeter cube. This is the right answer. That right? This is the right answer. Okay, let's see another question. A cylindrical bar with 200 mm diameter. So diameter of the bar is 200 mm. Being turned with a tool having geometry of this. So let's suppose if this is tool 1. So its geometry is given, that is 0, 9, 7, 8, 15, 30 and 0.05 inch, and remaining is in degree, and the tool 2, which is equal to 0 degree, 9 degree, 7 degree, 8 degree, 15 degree, 0 degree and 0.05 inch. Correct. So from this, CS1 is 30 degree, or you can say lambda 1, that is inclination angle, is equal to 60 degree. If CS, why? Because lambda is equal to 90 minus CS, that's why I am writing like this. And CS2 is equal to 0 degree. So for this, lambda 2 is equal to 90 degree. This is given here, and the other parameters remain unchanged. FC1 and FC2 are the corresponding specific cutting force, and UC is given here, that is U0 T1 whole to the power minus 0.4, where T1 is an uncut chip thickness, the value of percentage change in cutting force. So as you know that T1 can be written as F cos CS, or it can be written as F sin lambda. So can I say T1 uncut chip thickness is directly proportional to sin lambda? Is it right? And what is specific energy? This is cutting force into cutting velocity over V into F into V. So this is cancelled out with this, and this is equal to U0 T1 to the power minus 0.4. So can I say the cutting force is directly proportional to T1 to the power minus 0.4, or you can say cutting force is directly proportional to sin lambda whole to the power minus 0.4. So from this, FC2 minus FC1 over FC1 into 100 can be written as sin 90 whole to the power minus 0.41 minus sin 60 whole to the power minus 0.41, sorry, minus 0.4, not 1, over sin 60 degree whole to the power minus 0.4. So if you simplify this, then here I am getting minus 5.59 percentage, and this is the right answer. Okay. In ASA system, the side cutting and end cutting edge angle of sharp turning tool are 45 degree and side cutting edge and end. So CS is given 45 degree and C is given 10 degree. Correct? The speed during cylindrical turning F is given, that is 0.1 millimeter per revolution. The R is equal to H max by 4 and H max is equal to F over 10 CS plus cot C. So this is 0.1 over 1045 plus cot 10 degree. So after simplifying this, here I am getting H max is equal to 0.0149 millimeter. So what about RA? RA is nothing but this is H max by 4. So this is 0.0149 by 4. So this is in millimeter. So if I multiply with 1000, that we get this value in micrometer. So after simplifying this, here I am getting 3.74 micrometer. So this is the right choice. Okay, so let's see another question. The length, width and thickness of steel samples are given 40 by 40 by 20. If its thickness needs to be uniformly reduced by 2 millimeter in single pass by using horizontal slab milling. Is it right? So let's suppose if I draw 400 by 40 by 20. So, and we need to remove 2 millimeter. In single pass by using horizontal slab milling. The milling cutter diameter which is equal to 100 millimeter, width is 50 millimeter, has 20 teeth, Z is equal to 20 teeth, and it can rotate with 1200 rpm, and feet per tooth is given here, that is 0.05. This is ft millimeter. The feed direction is along the length of the sample. If the over travel distance is the same as the approach distance and the time taken to. So in this you can see here, approach distance is nothing but this is square root of small d times capital D minus small d. So let's say if I put the value here, so what is depth of cut? This is 2 millimeter. Depth of cut is 2 millimeter. Depth of cut is 2 millimeter. So 2 into 100 minus 2. So if we simplify, then here we get 14 millimeter. And this is equal to over travel. So the machining time is nothing but this is L by Ft into Nz. So what about length? So length is 400 plus approach plus over travel over Ft is 0.05 and number of teeth is 20 and speed is 1200 rpm. And we need in this time in seconds, so we just multiply with 6. So simply here we get 21.4 seconds. So the correct choice is option A. Okay, so let's see another question. The following data corresponds to an orthogonal turning of 100 mm diameter rod on a lathe. Rack angle is given here, that is 15 degree. Uncut chip thickness is 0.5 millimeter and nominal chip thickness after the cut means T2 is 1.25 millimeter. The shear angle is, so simply first we calculate R, which is nothing but T1 by T2. So this is 0.5 over 1.25. So from this here I am getting 0.4. And once we get, so as you know that tan phi is equal to r cos alpha over 1 minus r sin alpha. So this is 0.4 cos 15 degree over 1 minus 0.4 sin 15 degree. So what is phi? So after simplifying this here, I am getting 23.31 degree. So this is the right choice. Okay, so you can see next one. Teeth of the internal spur gear can be accurately cut by slotting machine, gear shaping machine. So the correct answer is gear shaping machine. Cutting speed in grinding is set to a high value to reduce the cutting time, increase the bond strength, improve cooling of the job and wheel. The cutting speed in grinding set to a high value. So yes, it is the correct answer is improve cooling of the job and wheel. So this is the right answer. Okay, so let's see this question. A 15 mm diameter HSS drill is used at a cutting speed of 20 meter per minute. So here the diameter of the cutter is given, that is 15 millimeter. HSS drill is used at a cutting speed. Cutting speed is given here, that is V is equal to 20 meter per minute. Correct. And a feed rate of F is also given here, that is 0.2 millimeter per revolution. Under these conditions, the drill life is, the tool life of the drill bit is 100 minute. The drill length of the each hole is 45 minutes. So let's say L is equal to 45 millimeter, sorry. And the time taken for idle motion, so this is Ti, which is equal to 20 second, correct? And the tool changing time, that is Tc, is equal to 300 second. Calculate the number of hole produced. So here we need to find out Z, number of hole produced, and the average production time. Average production time in per hole. Average production time per hole. Correct. So these two things here we need to calculate. So let's see its solution. So first of all, you can see the length is nothing but it can be written as a length that can be traveled by the tool is nothing but it can be written as small l plus half of the diameter. Half of the diameter. Correct? Half of the diameter. Is it right? So from this it can be written as 45 plus, and this is approximate value, correct? Because exactly हमारे पास क्या होगा d/2 cot phi, तो वहां से वैल्यू 0.577 टाइम्स ऑफ डायमीटर आता है, तो यहाँ पे हम इसको यूज कर सकते हैं. सो यू कैन सी 45 प्लस 15/2, so it can be written as 52.5 millimeter. So you can see the machining time can be written as L by Fn. So how we calculate F? So F is nothing but cutting velocity is given here, that is pi dn by 1000. So is formula से now from this formula we can get speed, that is 1000 into V over pi d, correct? So n is nothing but n is equal to 1000 into V, that is 20 meter per minute over pi d. And what about d? D is 15 millimeter. So now if we solve this, then here we get, if we can solve this, so here we get 425 rpm, revolution per minute. So what about machining time? So let's see, the machining time is nothing but the length is given 52.5 millimeter divided by F is given, that is 0.2 millimeter per revolution, and N is 425, And now if you solve this, then after solving this, here I am getting 0.617 minute. 0.617 minute. Correct? This is machining time. And once we get the machining time, the number of hole that can be produced is nothing but the tool life divided by time taken for making one machine, that is TM, making one hole, sorry. So 100 divided by 0.617, if you divide this number, then here I am getting 162 holes. Correct? तो इतने होल यहाँ पे से आप प्रोड्यूस कर सकते हो. नेक्स्ट, फॉर एवरेज प्रोडक्शन टाइम, लेट्स सी, फॉर एवरेज प्रोडक्शन टाइम, can I say this T average is nothing but time taken to machine one hole plus ideal time plus tool changing time. So that is TC by the number of hole, that is Z. Correct? So now you can see, so here I am going to write T average is equal to 0.617 minute plus idle time is 20 seconds, so it can be converted into minutes by dividing 60, plus TC is 300 divided by 60, because again we need to convert this value into minutes, into 162. So after solving this, here I am getting 0.9812 minute, or it can also be represented by second, that is 59 second. So this is second part of this question. Correct? So like this you can solve this question. Okay, so now in this question you can see a 50 flat piece 1 millimeter width and initial dimension. So let's see, first here I am writing initial dimension. Initial dimension is given here, that is 205 into 30 into 1. And similarly, if I talk about final dimension, then you can see here, then it can be written as 205 into 25 into 1. Correct? Using end mill cutter, if the diameter of the cutter is given, that is 25 millimeter and has 10 teeth. So Z is equal to 10, and speed is also given here, that is 100 rpm, revolution per minute. Find the maximum uncut chip thickness. So first here we need to calculate T1 max uncut chip thickness in millimeter, and we also need to calculate, and you can see horizontal table feed F is given, that is 10 millimeter per minute. Then assuming one teeth in contact, then MRR will be, material removal rate will be, correct. So let's see how to solve this question. So as you know that the T1 max is nothing but, it can be written as 2 times of Fy and Z is square root of small d, that is depth of cut, by capital D, diameter. So now if you put these values here, then simply here I am getting T1 max is nothing but, this is 2 into what is feet? Feet is given here, that is 10 millimeter per minute over n, that is 100, into Z, that is 10, square root of, what about depth of cut? So you can see from 30 millimeter to 25 millimeter reduction takes place. So the depth of cut is 5. From this the depth of cut is 5 and the diameter is given here, that is 25. Correct? Diameter is 25. So if you simplify this, then after simplifying, here I am getting this is 0.009 millimeter. This is the T1, and once you get T1, then MRR is nothing but this can be written as T1 into B into feed FM, correct? So simply after getting this, if I put all the values here, then this is 0.009, and you can see this. And one more thing, this is maximum thickness. If I write average thickness, then what about T average? T1 average is nothing but T1 max by 2, correct? So this is 0.009 by 2. So this is 0.0045 millimeter. Is it right? Now MRR is nothing but it can be written as T1 average. This is average tip thickness into width into FM. Is it right? So now if I put all the values here, then MRR is nothing but this is 0.0045, and width is nothing but here width is nothing but this is 1 millimeter, and in similar way we have 50 pieces. That's why here I am going to multiply 50, correct, into this is 10 into 10 into 100. This is called FM. So after simplifying this, here I am getting 2236 millimeter cube per minute, correct? So this is the right answer. This is the right answer. So this is T1 max. This is the answer, and similarly this is MRR. So like this we can calculate the MRR. Is it right? Okay, so let's see another question. Cylindrical bar of 100 mm diameter and 576 length. So diameter of the cylindrical bar is 100 millimeter, and and length of the bar is 576 millimeter, are turned in a single pass operation. The spindle speed used, that is N, is 144 revolution per minute, comma, the total speed, sorry, this is feed, not speed. This is feed is equal to 0.2 millimeter per revolution. Taylor's two-life equation Vt to the power n, that is 0.75 equals to 75, where V is the cutting speed in meter per minute and T is the two-life in minute. So here we need to calculate number 1, the time for turning one piece, so that is machining time. Second, we need to calculate the average total change time per piece, given that is it takes 3 minutes to change the tool each time. So total change time, tool changing time we need to calculate. Total tool changing time we need to calculate, correct? And the third part, that is time required to produce one piece, given that the handling time is 4 minutes. So production time, total time required we need to calculate. Total time required per piece we need to calculate. So let's see one by one. So first here I am going to write, and you can see 100 millimeter length given, n is given here. This is 144 rpm, correct? So the machining time is nothing but this is L by Fn, and everything is given here 576 over f is given, that is 0.2, and n is given 144. So this gives us in minutes. So from this the machining time is nothing but this is 20 minutes. This is 20 minutes, correct? Now for determination of tool life, first we need to calculate cutting velocity, and v is nothing but this is pi d n by 1000. So pi d is 100, n is 144 over 1000. So from this here I am getting 45.2 meter per minute. And once we get, then Vt to the power n is equal to constant. So from this the tool life is nothing but this is C by V whole to the power 1 by n, and C is given 75, V is given 45.2 whole to the power 1 by n, n is 0.75. So when we solve this, then here I am getting the tool life will be 1.96 minute. Is it right? This is tool life. So how many tool changes required, first we need to calculate. So the number of tool changing required this is equal to total machining time by tool life minus 1. And why I am taking minus 1? Because एक टूल तो इनिशियली फिट ही रहेगा इसमें, करेक्ट? उसके लिए तो आपको टाइम कंसिडर नहीं करना है. So now you can see this is 20 by 1.96 minus 1, and after simplifying this, here I am getting 10. Approximately here I am getting 10. Correct? So the number of tool changing required, let's say this is n. Okay, let's write like this. Number of tool changing required will be 10. Correct? So now you can see here we need to calculate total tool changing time required. Correct? Total total tool change time is equal to, this is 20 minutes for machining plus 10 times we need to change the tool, and every time it takes 3 minutes. So this is 50 minutes. Correct? This is 50 minutes. And similarly the total time required per piece, this is called average production time. Then this is machining time plus idle time plus tool changing time, total tool changing time. Is it right? So, and it can also be multiplied with Tm by T, and this Tm by T shows the number of tool changing required. So this is 20 minutes. And what about idle time? Idle time is also given here 4 minutes. And tool changing, this tool changing time is already calculated, that is 50 minutes. So from this it can be written as 74 minutes. So this is the answer. This is the answer. Is it right? So like this we can solve this problem. Sorry, why I am writing 20? Because total tool changing time is already given here. I am writing here like this. Ti plus Tm, yeah, this one. So this time is already determined in the previous step. So simply it can be written as 4 plus 50. Or it can also be written like this. It can also be written like this. It can also be written like this. Ti is 4 minutes, which is already given. Tm is 20 minutes, and this is 10 into Tc is 3 minutes. So from this it can be written as 54 minutes. Is it right? So this is the right answer. So like this you can solve this problem. Is it right? Okay, so let's see another question. Okay, so the cross feed on a shaper consists of a lead screw having 0.2 thread per millimeter. So actually this is the pitch of lead screw, correct, which is given here, and and it can be, and it can be written as 1 by, actually this is the reciprocal of pitch. Is it clear? 0.2 is nothing but this is because millimeter per thread, that can be a pitch. So it is a reciprocal which is given here. So 1 by 0.2. So from this here I'm getting 5 millimeter per thread. This is called pitch, correct? And now a ratchet and Pawl on the end of the lead screw is driven from the shaper crankshaft that Pawl that the ratchet by one tooth during each return stroke of the ram. Means you can see here, actually we have this kind of arrangement. In this we have, this is called ratchet and Pawl arrangement, and in this we have threads like this, correct? And here we have ratchet like this, correct? So by one stroke it can rotate it by 1 by 20th, means one tooth, correct? जब ये एक बार वन टूथ रोटेट होगा तो आपका जो टूल है लाइक दिस, इसको समझते हैं पहले। ये टूल है तो ये टूल यहाँ से मूव करेगा, इस पॉइंट तक जाएगा एंड फिर रिटर्न आएगा। जब ये रिटर्न आएगा तो ये टूल जो रैचेट एंड पावल अरेंजमेंट है ये वन स्टेप मूव रोटेट करेगा, करेक्ट है? एंड वन स्टेप रोटेट करेगा तो आपका वर्क पीस यहाँ पे फीड मिल जाएगा। सपोज अगर आपने पहले इसको कट किया है तो अब आपका टूल इसके सामने आ जाएगा, करेक्ट? तो ऐसे करके अगर हम देखें तो एक कंप्लीट रोटेशन ऑफ रैचेट पावल, यहाँ पे हमें क्या मिल रहा है 20 फीड, मतलब एक बार जब रोटेट होगा तो आपको 20 डबल स्ट्रोक मिलने वाले। इज इट राइट? एक्चुअली हियर आई एम इंटरेस्टिंग फॉर डिटरमाइनिंग द एडवांसमेंट फीड, एक्चुअली फीड और यू कैन से द एडवांसमेंट ऑफ द वर्क पीस पर स्ट्रोक। ऐसा नो एक स्ट्रोक में कितना एडवांसमेंट हो रहा है हमें एफ कैलकुलेट करना है। इज इट राइट? तो अगर मैं यहाँ पे एफ कैलकुलेट करूं तो मुझे किस यूनिट में चाहिए? एफ इन मिलीमीटर पर स्ट्रोक। इज इट राइट? मुझे इस वैल्यू को चाहिए। और देखो यहाँ पे क्या है कि 20 टूथ है, यहाँ पे 20 टूथ है। इज इट क्लियर? मीन्स 20 स्ट्रोक आपको मिलने वाले हैं इन वन रिवोल्यूशन ऑफ सिंपली यू कैन से पावल, करेक्ट? जब एक बार रोटेट होगा तो आपको 20 स्ट्रोक्स मिलने वाले हैं। इज इट क्लियर? तो यहाँ पे अगर हम देखें तो वन टूथ के लिए 20 स्ट्रोक या वन स्ट्रोक के लिए आपको कितना रिवोल्यूशन घूमना पड़ेगा? 1 by 20 रिवोल्यूशन। इज इट क्लियर? और पिच क्या होता है? 5 मिलीमीटर पर थ्रेड। 5 मिलीमीटर पर थ्रेड का मतलब है यहाँ पे 5 मिलीमीटर आपका एडवांसमेंट मिल रहा है पर रिवोल्यूशन, करेक्ट? तो 1/20th में रिवोल्यूशन में क्या मिलने वाला है? तो सिंपली अब यहाँ पे मैं फीड लिख सकता हूं, दैट इज 5 डिवाइडेड बाई 20 मिलीमीटर पर स्ट्रोक। ये जो वैल्यू मिलेगा यहाँ पे देखो, वन स्ट्रोक में 1/20th रिवोल्यूशन है, करेक्ट है? 1/20th रिवोल्यूशन। और यहाँ पे क्या मिला? 5 मिलीमीटर रिवोल्यूशन, 5 मिलीमीटर एडवांसमेंट पर थ्रेड, करेक्ट? ये हम कह सकते हैं 5 मिलीमीटर पर रिवोल्यूशन। एक रिवोल्यूशन में 5 मिलीमीटर आपका एडवांसमेंट है और एक रिवोल्यूशन में 20th स्ट्रोक्स मिलने वाले हैं। तो सिंपली हम कह सकते हैं 5 डिवाइडेड बाई 20, तो आपको मिल जाएगा मिलीमीटर पर स्ट्रोक। इज इट क्लियर? तो यहां से इसकी वैल्यू आ जाएगी, दिस इज इक्वल टू 0.25 मिलीमीटर पर स्ट्रोक। तो ये एक्स्ट्रा वर्क हमें करना पड़ा जस्ट बिकॉज ऑफ दीज डेटास। नाउ तो ये एक बार फीट मिल गया तो ये प्रॉब्लम बहुत इजी हो जाएगा. फाइंड द फीट इन मिलीमीटर. तो ये फीट मिल गया, हमारा फर्स्ट आंसर हो गया. करेक्ट. इफ अ प्लेट 100 mm वाइड has to be machined 10 seconds. Find the cutting velocity in meter per minute. Meter per minute cutting velocity. The ratio of return to cutting ratio. Return the ratio you can see here. Width is given here, that is 100 millimeter, and the total machining time is nothing but this is has to be machined in 10 seconds. This is machining time, and the cutting velocity in meter per minute. The ratio of return to cutting. Return means T2 and cutting means T1. ये रेशियो आपको दे रखा है 2:1 मीन्स 2. करेक्ट. तो देखो यहाँ पे मशीनिंग टाइम जो होता है वो क्या होता है, दिस इज T1 प्लस T2 इंटू नंबर ऑफ डबल स्ट्रोक, दैट इज B/F. इसी को हम क्या लिख सकते हैं, अगर मैं यहाँ से T1 को कॉमन ले लूँ तो क्या मैं ऐसे लिख सकता हूँ, T1 प्लस T2/T1 इंटू B/F. और यहाँ पे T1 क्या होता है, मशीनिंग टाइम फॉर टाइम रिक्वायर्ड फॉर फॉरवर्ड स्ट्रोक. तो सिंपली हम कह सकते हैं L/V1, वेयर V1 इज द कटिंग वेलोसिटी, 1 प्लस T2/T1 इंटू B/F. एंड वंस वी गेट दिस, अब यहाँ पे इसकी वैल्यू पुट कर दो. लेंथ आपको गिवन है, how much length, yes, the length of stroke is given here, that is 150 millimeter. Length of stroke is also given here, that is 150 millimeter. Correct. So 150 by, and here I am writing, let's see. So Tm is 10 second. This is equal to 150 millimeter over V1 in bracket 1 plus 2 into width is also given here 100 over speed is given here 0.25. So after simplifying this, here I am getting V1 is equal to 9000 millimeter per second, या इसी को हम लिख सकते हैं 540 मीटर पर मिनट. इज इट राइट? दिस इज द राइट आंसर. इस तरीके से आप इस प्रॉब्लम को सॉल्व कर सकते हो. तो सबसे पहले आपको फॉर्मूला को सिंप्लीफाई करना पड़ेगा. इज इट राइट? तो हमने यहाँ पे बहुत ही बेसिक से स्टार्ट किया इसको. ओके, सो लेट्स सी अनदर क्वेश्चन. इन एन ऑर्थोगोनल मशीनिंग विद अ सिंगल पॉइंट कटिंग टूल, रैक एंगल इज गिवन हियर, दैट इज अल्फा इज इक्वल टू 10 डिग्री. Uncut chip thickness and the chip thickness ratios are, sorry, chip thickness are. So T1 है 0.125 millimeter and T2 is also given here, that is 0.22 millimeter respectively, using merchant first solution. Merchant first solution means 2 phi plus beta minus alpha is equal to 90 degree. ये हमें given है. For minimum cutting force, the coefficient of friction at the tool chip interface means we need to calculate mu. करेक्ट. तो म्यू के लिए हमें क्या चाहिए, बीटा एंगल चाहिए. क्यों? क्योंकि म्यू इज इक्वल टू होता है tan बीटा. और बीटा कैसे मिलेगा, फ्रॉम मर्चेंट सोल्यूशन. और मर्चेंट सोल्यूशन अप्लाई करने के लिए अल्फा और फाई चाहिए. तो फाई कैसे मिलेगा, तो सिंपली हम लिख सकते हैं tan फाई इज इक्वल टू r cos अल्फा ओवर 1 माइनस r साइन अल्फा. इज इट राइट? अब इस फॉर्मूला में अगर मैं वैल्यू पुट करूं तो देखो क्या आता है, r आपका T1/T2 होता है. करेक्ट. यहाँ पे अगर मैं लिखूं r जो होगा वो T1/T2 है. और अगर मैं इसको सिंप्लीफाई कर दूं, चलो मैं यहाँ पे लिख ही देता हूँ. करेक्ट. कटिंग रेशियो बोलते हैं हम इसको, T1/T2, और इसकी वैल्यू क्या है, दैट इज 0.125 ओवर 0.22. करेक्ट. इसको सिंप्लीफाई करेंगे 0.568. एक बार r मिल गया तो 10 पाई इज इक्वल टू 0.568 cos 10 डिग्री ओवर 1 माइनस 0.568 साइन 10 डिग्री. अब देखो ये क्या आता है, 31.8 डिग्री. यहाँ से आपको मिल जाएगा फाइव इज इक्वल टू 31.8229 डिग्री. जैसे ये मिल गया तो यहाँ से हम मर्चेंट सोल्यूशन से लिख सकते हैं क्या, बीटा इज इक्वल टू 90 minus 2 phi प्लस अल्फा। और जैसे मैं इसकी वैल्यू पुट करूंगा, मैं डायरेक्ट यहाँ पे वैल्यू लिखता हूँ आफ्टर पुटिंग दिस वैल्यूज हियर। तो बीटा इज इक्वल टू 90 डिग्री माइनस 2 इंटू 31.8229 प्लस 10 36। इसको सॉल्व करने से बीटा आपको मिलेगा 36.354 डिग्री। तो यहाँ से आपका म्यू क्या आ जाएगा, टेन बीटा, और यू कैन से 36.354 डिग्री। So from this here I am getting beta is equal to 0.736. So this is the right answer. So like this you can find out the beta. Okay, so let's see this question again. In orthogonal turning of cylindrical tube of wall thickness 5 millimeter, wall thickness T is equal to 5 millimeter, and axial and tangential cutting force, you can see here axial and tangential ortho, this is a turning process. So let's see here, this is a tube, this is a tube, and let's suppose we have a tool here, correct? So one force is acting here, this is called cutting force, and this is the side view. And similarly, if I write its a front view, then it is looking like this, and this is our tool, and one force is acting here, this is called FT, tangential force, and this is cutting force. And cutting force is given here 1601 Newton, and thrust force is given here 1259 Newton. Is it right? This information is given here. The measured chip thickness, that is T2 is given here 0.3 millimeter. The rack angle alpha is 10 degree, and the axial feed is given here 100 millimeter per minute, correct? And the rotational speed is 1000 rpm. Assuming the material to be perfectly plastic and merchant, first solution can be applied, means 2 phi plus beta minus alpha is equal to 90 degree. ये merchant solution है of the material is the shear strength. We need to find out shear strength tau s in megapascal. So as you know that shear strength is nothing but this is shear force per unit area, shear area. And what is shear force? This is Fc cos phi minus Ft sin phi over A, area क्या कहलाएगा, T1 into B over sin phi. So first we need to calculate phi, correct? And for determination of phi we need a T. We need a T. Is it right? First you can see here. So you can see here, as you know that the feed is nothing but, if feed is given in millimeter per minute, so first you need to convert this in millimeter per revolution. So simply you divide F with N, and let's say this is F prime. So this is F prime. So ये क्या आ जाएगा, 100 divided by 1000. So simply here I am getting this is equal to 0.1. So F is nothing but this is 0.1 millimeter per revolution. And since this is orthogonal cutting, so simply here I am saying for orthogonal cutting, the uncut chip thickness is nothing but this is F. So T1 is equal to 0.1. So once you get T1, so can I say R is nothing but this is T1 by T2, and what is R? R is not, what is T1? So 0.1, and what is T2? This is 0.3. So simply it can be written as 1 by 3, that is 0.333. Is it right? So now you can see 10 phi can be written as r cos alpha over 1 minus r sin alpha. So this is 0.333 cos 10 degree, which is already given in the question. 1 minus 0.333 sin 10 degree. Is it right? Sin 10 degree. So after writing this, if you simplify, then here I am getting phi is nothing but this is equal to 19.21 degree. This is phi. So now we have phi, and now the time is to determine width. So here the thickness of the cell is nothing but this is also called as depth of cut. D is equal to T, that is 5 millimeter. So for orthogonal cutting, simply here I am writing for orthogonal cutting, the width can be written as depth, which is equal to 5 millimeter. Correct? So now from above formula, the shear stress is nothing but this is 1601 cos 19.01 degree minus 1200 thrust force, that is 1259 sin 19.01 over T1, that is 0.1, width is 5 over sin 19.01. So if you simplify this, then after simplification we get 722.302 megapascal. Correct? 722.302 megapascal. So the correct answer is option C. So like this you can proceed this problem. Is it right?